Hello, this video is about variable scoping in R, also called lexical scoping. These are the rules for how R looks up the values of objects when calling functions. So let's start with a really simple example. I'm going to make a function, we'll just call it x times y. And this will be a function of x and y. And it's going to return x times y. Okay, probably something you don't need to write a function for, but we could. And if I call this x times y, so just to review, I'm defining this function called x times y using the function. I'm giving it arguments x and y. And in the body of the function, I'm just immediately returning the product of x and y. So if I want to call this, I could go like this. X times y, 3, 4, should return 12, and everything works fine. Okay, so what's happening here is when I call the function, it's going to execute the code in the body of the function using the values of these variables that were supplied as arguments. So we supplied 3 for x, 4 for y. It's going to return, when I do that, it's going to return 3 times 4. Okay, no surprises there. Now things get slightly complicated when the function references objects that are not passed as arguments. So I'm going to write a function called times y, function of just x, and it's going to return x times y. Okay, so this might look a little bit strange because we're referencing both x and y, but the function is only a function of x. So if I try to call this times y of, was only one argument, so I'm going to give it 3, we get an error. Error in times y. Could not find, well, okay, wrong error. That's because I didn't run this. Different error. Error in times y3, object y not found. Okay, so it's trying to execute this piece of code, x times y, and it has x because I supplied it as an argument, but it doesn't have y, and so it doesn't know what to do. However, something interesting happens if you define y over here. So if I say y equals, let's say y equals 3, and then I call times y with x equal to 4. Let's do the other way just to be consistent. Y is 4 times y with 3. So run this. When I call it now, it gives me the answer that I expect. So what's going on here? Times y, this version of times y, it uses the x value 3 that I passed to the function here when calculating x times y. When it encounters this y, it has to look outside the function for the value of y. The first time I called it, before I defined y, no such object y existed outside the function. But the second time I called it, I had already defined y as 4, so it just used that value. Okay, so that is, those are the rules. The first basic rule, that it will always look, if it encounters a variable or an object that is not passed as an argument to the function, it will look up one level. And so if I run it again, if I do, after I redefine y as 8, now you get 24, 8 times 3. Okay, so when the way R handles this, it was, it uses what are called environments. So whenever a function is defined, like x times y or times y, it records the environment that the function was defined in. And you can access that environment by doing environment times y. So what is an environment? Environment is just a closed collection of objects. To see which objects are available, you would do ls. And let's actually look real quickly at the ls function. All right, ls and objects return a vector of character strings giving the names of objects in the specified environment. When invoked with no argument, at the top level prompt, lf shows what data sets and function a user has defined. Okay, so if you call ls with no arguments, it gives you the user-defined objects. So we have assigned this object, and this object y. We give it a different value down here, but it's still, there's just one object y. This global environment actually contains many more things than these three things. So in the documentation, it says it only gives you the user-defined object, but things like mean is an object that's available in the global environment, but it's not returned by ls because there's just lots of functions. So it only gives you the ones that are user-defined. Okay. So the environment of times y is global environment. That's the environment that is defined in. If you call it without any arguments, it just tells you what environment you're in. And you can also use this isn't used very often, but you can also use it to access objects. So here, this returns global environment, and then you could do $sign with the name of the object you want to access. Okay. Now, when a function is called, it creates a new sub-environment. So environment that's kind of lower in the hierarchy than the global environment. So let's look at an example of that. I'm going to redefine times y. And inside the function, I'm going to record which environment I'm in. So I'm going to call the environment function to record which environment I'm in. And I'm also going to record what is the parent environment of the current environment. So there's a function called parent.env, which records the parent environment. So this is going to be the function's environment, and then the function's parent environment is going to be the global environment in this hierarchy. And then I'm going to print these things out. And I'm going to also print out the objects that are available using ls. And return x times y. I want a function to do something. Okay. All right, so here's a new definition of times y. And then I'm going to call it times y with 3. Okay, so when I call this function, again, it takes this value 3, assigns it to x in the function's environment, and then it executes the body. So here we record E1 and its parent and print it out. So this is the function's environment. It gets this like weird hash value. The parent environment, the parent of that environment is the global environment. It has a special name. So these two print lines produce these two things. And then this produces the objects in the function's environment. And there's only 3 of them. You have these 2 variables that we just defined up here. And then we have the argument object that was passed to the function. We could do the same thing for the parent environment. This is the the objects available in the global environment. And again, it just shows you the user-defined objects, but those are available there. Okay. And then it returns 24 because y right now should be equal to 8. Okay. Now, if we go and remove y, so there's a function called rm, which removes objects. And I'm just checking to see if you can specify an environment. Yes, you can specify an environment. So you can say which environment you want to remove objects from. But by default, it just does whatever environment you're in, which is the global environment in this case. So if I do this and this, and then I try to times y again, I of course get an error because now in the global environment, there's no object called y, which we can confirm by calling ls. Okay, so these environments, each function gets its own custom environment. The other thing is that each time the function gets evaluated, it gets a new environment. So when I called it, okay, these look similar, but when I called it the first time, this was the environment, 0x55b5033. And when I called it the second time, it gave a different environment. So these are kind of temporary things that go away. Well, they don't go away, but they are still attached to the they're still attached to the function. Okay, but they're different each time you call it. Okay, I think this is all fine. This is not too complicated. When functions get called, they create sort of a local environment, and then it will first, when it's looking up objects, it will first look for objects in the function's local environment. So in this case, x is in the local environment. So when it tries to evaluate this, it's going to use the x that you passed to the function. Now, if it encounters an object that is not in the function's local environment, it looks in that function's parent environment. In this case, the parent environment is the global environment. And it will look up the value in the global environment. If it sees it there, then it will use it. If it doesn't, it will return an error if it can't find it. Okay. Now things get complicated though when you have functions that return other functions. So let's look at a few examples. So here's a function f. And when we call it, I want to print out the function's environment. And what the function does is it creates another function called g, which squares its argument, and then returns the function. Okay, so this is a bit different than we were doing before. Instead of returning a value, it's actually returning a function that's capable of computing a value. Okay, so let's run this. Environment f should say global environment. That's the environment the function was defined in. And then let's call the function. So g1 is a function, and we've printed out its environment there. Okay, so there's a few ways to see in the environment. So this is what got printed out when we called f because we put a print statement there. When you print out a function, it will print out its environment. So these two things match. And then just to confirm that, we can say environment g1. Okay, so that all matches. If we call it again and call this g2, we print the environment out. Notice it's different. You got a new environment each time you evaluate the function. And that, oops, it should say environment G2. This one matches this one. Okay. So that's just showing you that you can have a function that returns a function, but that function's environment is going to be different each time. Okay, so let's look at an example that's going to have some looking up of values. Oh, by the way, we can call G2. So G2 of 3 is 9. Okay, so that works as it should. And that's because everything that gets evaluated inside of G is in G's environment. So if you pass X, X is already in the environment, and doesn't have to look up any other values. Okay, now let's do a more complicated example. F1 returns a function. Okay, so let's analyze this before we call it. Okay, so this function, and let's just be explicit. Let's say return G. Okay, this function, F1, has a single argument x. It creates a function G which references that argument, but also another object y. Okay, so let's run through this. Let's set, so we know what's going on here. Let's say G is F1 of 4. Y is 3. G is F1 of 4. And G has no argument, so we can call it this way. Okay, G gives 12, and that's 3 times 4. So what actually happens? Let's look at the environment of G is that thing. LS environment G. It has G itself. Environment of G has G itself. Yes. Okay, so environment G is the environment that G was defined in. Okay. So that's F1's environment. Actually, we should, let's do this whole thing. Print environment. F1, let's start over. Y, G. So when I call F1, I get an environment printed. That's F1's environment. If I look at environment of G, these things should match. And if I look at the objects available in that environment, you have G and you have X. So we can actually use this to look at environment G $X. Should be 4 because that's the 4 we supplied. So let's run through this. F1 function X, print its environment. So when we call G here, it's looking for the values X and Y. X is available to it. That's in the same environment that G is in. Y is not, so it has to look up one level. So Y is being referenced from the global environment. And so if we say Y is 8, and then we call G again, the answer will change. So the value of X within G is 4. We change it to Y is 8, and so on and so forth. So that all works. Now let's do one other example. And we're going to take the same basic functionality and we're going to write it differently. We're not going to print this out, but I'm going to define an intermediate variable called Z, which is X times Y. And G is going to be a function that simply returns z, and f2 will return g. Okay, still pretty simple function, but here's where things get complicated. So I'm going to set y to 3. I'm going to call g1. Sorry, I'm going to set g1 equal to f2 of 3. f2 of 3. So f2. All right, so what happens here? I'm calling f2, so I define z as x times y. In this line, it uses the supplied x, which is 3. It doesn't see y, so it looks up this value. And then we define a function which simply returns z. Okay, so if I call g1, this gives 9 as expected. Now, let's do the same thing. Let's change y to something else. And now let's call g1 again. We still get 9. Okay, so why is that? Let's actually look at g1. g1 is simply a function that returns the value z. So whenever we call g1, it has to look up the value z. Well, z is defined in the environment of g1 simply as 9. Okay, so it just looks up the value 9 and returns it. If you look at the source code for a very simple function g1, it doesn't reference y at all. So the fact that we redefined it here makes no difference when we call this thing. It's just looking for an object called z. Namely, it doesn't try to rerun all this code when it evaluates g. It just simply looks for an object called z. Okay, so this is very important to understand. It's not going to redefine the function g with new values of y. Now, if we call f2 again, so let's say g2 is f2 of 3. When it calls this, now it reruns this line. X is 3, but now y has changed to, let's see, y has changed to 8. Y is 8. No, it's not. Okay. Now y has changed to 8. And if I call g2, now we get 24. Okay. So what happens here is, again, g2 is simply a function that looks for something called z. And in g2's environment, z is simply 24. It doesn't go back and try to rerun this code and look for the fact that y has changed. Okay. All right, so these are kind of complicated rules to remember for the case when your function returns another function. So what I would just caution you is, if you're writing code that returns functions, you need to really think carefully about environments. If you're writing code that just returns values, vectors, and matrices, and so on and so forth, you do need to think carefully about your function referencing things that are not arguments to the function, like this here. Y is not referenced. But the rules are a lot simpler. It just looks up one level. So you should remember that when you change those objects and call the function again, it will give you a different answer. But the rules there are actually pretty simple. Here it's a bit more complicated. So what you should do is, if you're writing functions that return functions, kind of your alarm bell should go off that I need to think about what's going on very carefully, and then remember what the rules are. And it's all about environment and closing environments and looking up values. Just follow the rules. Okay, that's it for this video.